In today's video, we will discuss about Kjeldahl'S method of nitrogen estimation in organic compounds. So in Kjeldahl'S method, first of all, we treat our organic compound with concentrate H2SO4 and CuSO4 as well as with potassium sulfate. So basically, when our organic compound is treated with H2SO4 in the presence of copper sulfate or mercury, one drop of mercury Hg and K2SO4, then our organic nitrogen of our organic compound gets converted into ammonium sulfate, NH4 whole twice SO4. So what is the role of copper sulfate and mercury? Both act as a catalyst. And what is the role of K2SO4? Actually, potassium sulfate increase the boiling point of H2SO4. So the complete nitrogen of organic compound gets converted into ammonium sulfate. Now this mixture after digestion, means that process is known as digestion. So this mixture after digestion is transferred in a round bottom flask. There this mixture will be treated with NaOH. So what happen? Actually ammonium sulfate is a salt of strong acid H2SO4 and weak base. So it is a basically it is a acidic salt. Acidic salt. So when this acidic salt react with NaOH, means base, it produce ammonia NH3. Now we have to find out the mass of this ammonia. Mass of this ammonia. If we find out the mass of ammonia, then we can find out the percentage of nitrogen in our organic compound. So what we have to do? Ammonia cannot be titrated directly because ammonia is present in gaseous form and gases cannot be titrated very easily. That's why what we have to do, we have to mix this ammonia with excess of a standard acid like H2SO4, like this. This ammonia will transfer in a conical flask using a condenser. Now, in this conical flask, a non-volume of standard acid is present. Means we know the number of equivalent of H2SO4. Suppose number of equivalent of H2SO4 we are taking are 10 equivalent. Now according to law of chemical equivalence, we know the one equivalent of ammonia react with one equivalent of H2SO4. So some equivalent of H2SO4 will remain unreacted. The H2SO4 unreacted H2SO4 is titrated against a standard alkali like NaOH. So suppose we are taking 10 equivalent of H2SO4. The unreacted H2SO4 is titrated with NaOH, and in titration the number of equivalent of NaOH is 7. 7 equivalent of NaOH are using in titration. So it means the number of equivalent of unreacted H2SO4 was also 7. It means we are taking 10 equivalent but unreacted H2SO4 are 7 equivalent. So it means the number of equivalent of H2SO4 which are reacting with ammonia, that are 3 equivalent. So the number of equivalent of ammonia is also 3. In such a way, we can find out the number of equivalent of ammonia. Let's understand, suppose we are using the number of equivalent, we can find out the number of equivalent of ammonia. So let's suppose the number of equivalent of ammonia, number of equivalent of ammonia, which are equal to number of equivalent of H2SO4 that react with ammonia. So suppose these number of equivalent are N into V. Now what is the N? N is the number of, N is the normality of H2SO4 as well as V. V is the volume of H2SO4 in liter which is reacting with ammonia. So number of equivalent of ammonia we get, that is N into V. Now we can calculate the mass of ammonia. So mass of ammonia is equal to number of equivalent, means NV, into equivalent weight of ammonia, that is 17. So that is the mass of ammonia we are getting from our sample. We can calculate the mass of nitrogen. Mass of nitrogen. How can we calculate mass of nitrogen? In 17 gram ammonia, what is 17 gram? 17 gram means that is the molecular weight of ammonia. Molecular weight of ammonia. The nitrogen present is 14 gram. So if we are taking 1 gram ammonia, then in 1 gram ammonia nitrogen is 14 by 17. We have the ammonia mass NV into 17. So if we are using NV into 17 gram ammonia, then in this mass the nitrogen present is 14 by 17 into NV into 17. Now 17 is cancelled out by 17. So that is the mass of nitrogen which we are getting from our sample. Now we can calculate the percentage of nitrogen. How can we calculate the percentage of nitrogen? Actually, we are taking a W gram sample. So from W gram sample, we are getting nitrogen. That is equal to 14 into NV gram. Suppose the weight of sample is 1 gram. So 1 gram sample. We will get nitrogen that will be equal to 14 into NV divided by sample weight. Sample weight means that is W gram. Now, because we are calculating the percentage of nitrogen, so calculating the percentage of nitrogen, we have to take the sample weight 100 gram. So suppose we have 100 gram sample. So in 100 gram sample, the nitrogen will be 14 into NV upon W into 100. So that is our actually formula of percentage of nitrogen. Here V is volume of H2SO4 which reacts with ammonia, that should be in liter. But if suppose we have the volume of H2SO4 in milliliter, then what we can do, percentage of nitrogen is equal to 14 into N into V. V is present in ml into 100 upon W. W means sample weight. W means sample weight into. Now we have to convert this volume into liter. That's why we have to divide volume with 1000. So ultimately we will get the formula, that is percentage of nitrogen is equal to 14 into N into V. V in ml divided by W into 10. So 14 by 10 we can write down like 1.4. So our formula will be 1.4 into N into V divided by W. W means sample weight. Sample weight. We can use this formula 1.4 into normality of standard acid into V. V means volume of standard acid that is used to react with ammonia divided by sample weight. This is the percentage of nitrogen in our sample. What is the limitation of this Kjeldahl method? So there are some limitations also. What are limitations? First, nitro compound cannot be estimated. Nitro compound, in nitro compound nitrogen cannot be estimated with Kjeldahl's method. Second, in diazo compounds, diazo compounds, diazo compounds like benzene diazonium chloride, diazonium chloride. So nitrogen in these compounds, as well as when nitrogen is present in a ring like pyridine. So when nitrogen is present in the ring, then nitrogen percentage cannot be calculated because these compounds are not able to form ammonium sulfate. They cannot be converted by they cannot be converted into ammonium sulfate using these reaction conditions. They cannot be converted into ammonium sulfate. That's why they cannot release the ammonia. That's why we cannot proceed, or we cannot find out percentage of nitrogen in these compounds, because in diazonium compound this they release nitrogen, directly nitrogen. So ammonia cannot be produced. Similarly, nitro compound, and when nitrogen is present in ring, these compound nitrogen cannot be converted into ammonium sulfate. That's why this method is not applicable in these compounds. We can directly use this formula. You have to learn this formula. Percentage N is equal to 1.4 into N. N means normality of H2SO4 which is used, as well as V. V means volume of H2SO4 divided by sample weight. The concept behind the Kjeldahl method was that. Thank you.